Good afternoon, everyone. My name's Taly Hunter-Williams, and I work in the Groundwater Programme at Geological Survey Ireland, along with my co-author, Caoimhe Hickey. We'd like to thank the IAH committee. Thank you for inviting us to present at this conference, which for me is a completely new experience, having to do it online. As with all presentations, I'd like to acknowledge the contribution and work that really is reported on in this talk by many of these people and others not listed here as well, in the fields of karst and fractured bedrock aquifers. Harrison Bishop is listed down here. He's a graduate geologist who started with us last year and now is working on as a contractor. He's done some depth inflow graphs, and I would like to invite any people watching at the moment to submit information on what they've found when they've been drilling boreholes around the country in limestone aquifers. So can you please prefix that with BH and then a colon, and then put kind of things like the borehole depth, depth to rock, main inflow depths, rock type, and where you were drilling in the country. And we'll see what we come back with. Might be interesting to get a kind of straw poll and see how that fits in with the information we've got. So one of the main points of interest in our groundwater systems is the use we can make of it for drinking water supplies. Of the groundwater abstractions, group scheme and public supplies take between 2/3 and 3/4 of their groundwater via boreholes and springs from carbonate aquifers of one type or another. And that totals over 400 cubic meters per day, which is a significant volume, although that is slightly eclipsed by the very, very significant abstractions that supply Dublin and Galway and other major urban areas from surface water abstraction sources. Nonetheless, groundwater supplies and abstractions are distributed very widely across the country, and there are numerous abstraction points, and that's a benefit in terms of being able to co-locate a groundwater or an abstraction source near to the urban area it's supplying. Of the carbonate rocks, about half of the boreholes are in karst limestone and half are in non-karst limestones, whereas the spring abstractions are predominantly in the karst. Excuse me. As well as groundwater systems in limestone aquifers being important for groundwater abstractions, they're also important for ecosystems, turlocks being one of the most obvious ones, particularly in winter. And you can see they're very strongly located in the west of the country, although they are distributed for as far south as Waterford and as far north as Ulster. Another important ecosystem are petrifying springs. These are made of tufa, which is a porous calcareous rock. It's been deposited by lime-rich springs, and they have a distinctive floral and faunal assemblage. They're often rare species, and that's led to them being incorporated in as a priority habitat in Annex 1 of the EU Habitats Directive. Alkaline fens are another type of ecosystem reliant on limestone aquifer groundwaters. These are groundwater-fed wetlands as well as receiving rainwater, and that means that they're less acidic and have higher nutrients and mineral content than other bogs such as raised bogs or blanket bogs, and this means they can support greater floral and faunal biodiversity, and they can also help mitigate and reduce flooding depending on their location. 2 of our 3 UNESCO Global Geoparks are carbonate, those that in the Burren and also the ones in Marble Arch Caves, which are in Cavan Fermanagh. And these have been sculpted significantly by the passage of rainwater and groundwater to give us the landscapes that we see now and are important in global terms. We also have show caves and other landscape features. So in Ireland, we have rocks spanning billions of years, 1.75 billion years to be precise, or approximately precise. We're focused or mainly interested in the lower Carboniferous, although there are carbonates from other periods as well, the Cretaceous rocks Paul Wilson will talk about later on. So of the rocks underlying the Republic, about 45% are limestones, and of those, 55% of those are pure limestones. Pure limestones are of interest and importance because they're much more susceptible to karstification, which then increases permeability and the aquifer resource value. The legend here is hydrostratigraphic units, or rock unit groups, and we've condensed more than 1,000 rock formations into about 28 rock unit groups, which on the basis of similarities and importance for characterising groundwater flow. So these might be purity of limestone, whether they're bedded or not bedded, and there are other factors which influence the aquifer properties as well, which I'll go on to describe. So limestone's mainly made of calcium carbonate, shell fragments that have accumulated. Usually they're found where there's little or no terrigenous clastic input, either input from nearby land masses, although that's not always the case, as we'll see in the next few slides. Dolomite is important in Irish aquifers because the calcium, when it's replaced by magnesium, causes an increase in porosity and permeability, and therefore improves the aquifer properties, characteristics for groundwater flow. So at the end of the Devonian period, Ireland would have looked like this. It would have been arid, hot, and certainly not marine, but there was a marine incursion from the south that moved gradually northwards over millions of years, and this led to the deposition of shaly and sandy limestones as the landscape flooded. And you would maybe know these as the lower limestone shales, which were deposited, say, in Limerick, particularly the Limerick area, and Clare in the Midlands. And these were succeeded by the Ballystein limestones, which are also known as the argillaceous bioclastic limestones, ABLs. And we've called these the Dinantian early sandstone and shale limestones, and the Dinantian lower impure limestones. So you can see that these vary in thickness laterally from the southeast to the northwest, and they also vary vertically. And that can be seen in the natural gamma log here, which is a record of shale content. As the sea deepened and the shoreline receded northwards, there was deposition of what's called these Walsaucian limestones. These are very massive mudbank limestones, very little bedding in there at all, and that's important in terms of their resistance or susceptibility to fracturing, and therefore creating flow pathways through what otherwise is a massive and zero porosity and permeability bedrock unit. As the Carboniferous progressed, the shoreline again was kind of proceeding northwards, and the shallow sea conditions established themselves, looking something like this Nemo setting, a coral reef. And over most of Ireland, there were these shallow seas with pure bedded limestones, and then there were smaller areas, restricted areas of deeper water basinal shaly limestones being deposited. So these gave rise to these Burren type limestone, which have got these clay wayboards that arise from when the limestone platform was periodically exposed, and that was a development of soil basically. And then we've got these basinal, very shaly, dark, slabby limestones. And you can see here that groundwater has flowed along the bedding plane in these pure bedded limestones and cascaded down the face of the quarry. That's a much larger scale viewpoint of a bedded limestone aquifer. And these are the upper impure limestones, very shaly and slabby, and they don't karstify except very locally. They're acting as a fractured bedrock aquifer, not karstified in a kind of a groundwater flow function. The important structural events for limestone aquifers are the Variscan orogeny. This is a major tectonic event coming from the south. So most of the deformation is concentrated in the south of Ireland, although there were some localised kind of crumple zones in other locations. For example, at Rush there in North County Dublin. There's also veining across Ireland. It's most obvious in the Burren in County Clare, where the exposures are really good. And you can see here, this is about 2 kilometres across. And these calcite veins have been dissolved out. And these cut through all of the different beds to quite significant depths in each individual vein. And that allows water to percolate down and then the limestone to be dissolved on either side of that vein face and develop significant and conduitized karst systems. And this is shown here, the cave system. This is a plan view of cave system, which is very strongly influenced by the veining orientation. The opening of the Atlantic in the tertiary times also had a strong influence on the fracture and fault development in Ireland, and some of those fault systems related to this extension are significant groundwater flow pathways. John Paul Moore and his then PhD supervisor John Walsh, and they continue to collaborate at UCD Fault Analysis Group and ICRAG, have summarised the important structures for groundwater flow in Carboniferous and post-Carboniferous rocks. And the key ones are the tertiary strike slip faults, the north-northwest and northeast orientation, and these north-south veins. They can be the location of significant karstification in pure limestones, and in impure limestones, they can still act as significant flow pathways. We also have jointing, and that's related, the thinner bedding has more jointing. And so that's why there's a distinction between massive and unbedded limestones and pure bedded limestones. The distributed nature of this fractures in this quarry face here would allow groundwater to flow through in quite homogeneous way, whereas in this example here we've got very localized conduit flow, which would make development more difficult. There's increasing levels of unpredictability, so that drilling in the conduit limestone, you could end up with a failed borehole very close to what would be a very productive conduit should it be intercepted. So a summary of factors influencing limestone aquifer characteristics. Sedimentary structure, so presence of bedding is very, very significant. It allows more fracturing and jointing, and also groundwater can flow along the bedding planes, and more massive rocks are much more resistant to deformation. And for the same amount of deformation, there's fewer flow pathways being developed in them. Purity of the limestone allows more, it means that the rock is more brittle, fractures stay open, but the key factor there is it's more susceptible to solution and karstification. And conversely, impure limestones, karstification is inhibited and fractures are often infilled by migration of fines. Dolomitization increases porosity and permeability, and the structural history influences the type and intensity of deformation and whether these structures are flowing or sealing. And karstification is dependent on all of those factors above, plus topography, the relative sea level during the time that karstification was taking place, and the amount of subsoil covering the limestone aquifer and the length of time that the aquifer has been uncovered, if it has been uncovered. And the closer to the ground level or the top of the rock head, there are more fractures, and apertures can be wider because they don't have the overburden keeping those closed. So I'm going to go through some examples now of different aquifers in different locations around Ireland. I've only got time to go through a few of these, so I'm going to be talking about the Denantian, the Denantian lower impure limestones, the Ballysteen, the Woolsortian, the pure unbedded limestones, the upper impure limestones, so the calps, and the pure bedded limestones as well as these Burren types. So I'm going to start off over here in the west, where we've got the regionally important conduit dominated karst limestones. So these are examples of conduits at different scales. This is in the epikarst and still there's conduit and focused flow as well as more diffuse flow. And here's an active conduit, and these are inactive. The limestone aquifers in the south of the country, the Walsatian limestones, are massive, but because they had such intense deformation, they are fractured quite significantly into a kind of type of sugar cube, almost quite rectilinear type of pattern. And this can be seen in the cave map here. This is a plan view of a cave map, and this kind of orthogonal pattern showing up is quite clear. So although these rocks are diffusely karstified, we call them diffuse, and we say that the flow is going through those in a fairly distributed way. They can still have conduits in. You can see that it's very very regular. Even the cavities are regular. Limestone aquifers, if they have a sufficiently well-drained soil and subsoil above them, have very, very low drainage densities. And this example here is from Galway, and we can see here that this is the original drainage density, not the channelized or modified one. And that's still here. So you've got the flooding areas, but between those, between the rivers and the Turlock areas, drainage density is very, very low. And that would be the case in large parts of Tipperary, Laois, Kilkenny as well, where it's underlain by limestone, karst limestone. As well as recharge taking place diffusely through the soil and subsoil cover, conduit-dominated limestone aquifers can also receive quite a significant proportion of their recharge through points, such as swallow holes and enclosed depressions. And this has an influence on how groundwater travels through the subsurface and emerges at, for example, springs. And we can see the effect of diffuse recharge through a soil and subsoil cover. That results, if we're measuring here at this spring point here, that slows and spreads out the curve significantly. Similarly, even if the limestone is not significantly conduitized, but the groundwater is flowing through a distributed network of solutionally enlarged fissures, then the breakthrough curve is muted and spread out, and that's in very strong contrast to flow through focused conduits, which will reach the outflow very quickly and have very little interaction with a lot of the rest, the large volume of the aquifer. So recorded groundwater velocities in the western lowlands, the RKC karst, can be significant. Up to more than 1,000 meters per hour have been recorded, although typically they're usually up to around 240 meters per hour. So kilometers to tens of kilometers per day traveled in the subsurface. And this is in contrast to the southern karst. Well, firstly, we can see that actually we've only got 5 measurements in the pure unbedded limestone aquifers of the southern synclines, and that's, although there are some conduits in those are further and fewer and further between, and the flow velocities are at the lower end of the range seen over in the west. In terms of the depth that groundwater is flowing through the aquifers, the vast majority is thought to be flowing in the top 10, 20, 30 meters, and this is where the majority of the inflows are occurring. Although in around Glenamaddy, a conduit was found and encountered at 100 meters below present day sea level. And this is similar, we see a similar pattern actually to the diffuse karst over here, although we see kind of maybe less deeper significant inflows. They're more distributed to the shallower depths. So now I'm going to talk a little bit about the impure limestones and the Walsatian limestone, the pure limestone that is not significantly fractured and therefore is a locally important aquifer, not significantly karstified and it behaves like a fractured aquifer, not a karst aquifer. This just illustrates the depth of fissure development and therefore the depth of the flow system, dependent on that fracture development. And this would be for example, in a generally moderately productive bedrock aquifer, LM, we'd expect a deeper flow system than in the LL aquifers. And does that emerge? Well, actually, interestingly, we seem to have, this is all locally important aquifers, we seem to have inflow depth recorded at a greater depth below rock surface than in the upper impure limestone LM aquifers. And I suspect what's happening in here is that we're getting much more significant inflows in the shallower depths, and they're masking any inflows further down. And also the boreholes probably are not being drilled as deeply because adequate volume is being met at shallower depths, whereas in the locally important aquifers that are low productive only in local zones, the LL aquifers, drilling has to go deeper to encounter sufficient supply, and then also if supply is not met at shallower depths, then that's more obvious as the borehole is drilled deeper. In terms of the transmissivity or productivity of the aquifers, now Corin is going to be talking about these aquifer properties in his talk next, but I'd just like to show the distribution of well productivities in some of the different limestone aquifers. The productivities range from 1, which is the best productivity and is akin to high transmissivity, and they range down to 5, which is akin to a low transmissivity. And these productivity classes are established by Jeff Wright, who used to work in geological survey until his retirement. And they're a very good way of kind of looking at the heterogeneity as well or homogeneity of an aquifer system as well. So we can see here in the western cast, the RKC aquifer, we can get some very extremely high yields and very good productivities, but actually they're very heterogeneous. There's very low productivity classes as well, and they would be accompanied by similarly low yields. Conversely, the RKD, the diffusely cast aquifers in the south, although they're unbedded, they're much more homogeneously fractured, and therefore we get absolute dominance of productivity class 1, and that would be associated with high yields as well. In the kelp type limestones, the impure limestones, and the unbedded pure limestones that are not significantly fractured, we get a greater preponderance of productivity classes at the lower values here, 4s and 5s, and they be associated with kind of modest yields, so kind of say up to say 50 to 200 to 300 meters cubed a day, but lower transmissivities overall and heterogeneous. So in summary, limestone aquifers are significant in Ireland because they make up almost half the immediate subsurface bedrock. They also are dominated by Carboniferous age bedrocks units in the Republic. They supply between 2/3, I should say, and 3/4 of group and public groundwater fed supplies. And they support important ecosystems and also support river base flows as well, particularly the regionally important aquifers. Karstification is important. About half of the carbonates are significantly karstified, and the other half are acting more as fracture-dominated, fissure-dominated groundwater flow systems. And in the karstified aquifers, flow volumes and flow velocities are high compared to the fractured carbonate aquifers. But that means we can have great winds, but it also means the development can be a lot more challenging in the conduit-dominated karst. And we've got a lot more to learn. We've got more to learn about inflow depths, the depths that groundwater through flow is concentrated at, certainly karstification depths across Ireland in different units related to different base levels, and other aspects too. So thank you very much. I hope that was useful as a kind of introduction and an overview of carbonate aquifers in limestone to set the scene for all of the excellent speakers in the rest of the conference. Thanks very much.